Okay, so I want to talk about one final rule that's often pretty useful for figuring out probabilities. Like all of these, Gensler covers this one. He goes pretty quick, though. And this is the so called negation rule. And so, to see what the negation rule is, and also to show you guys why it's useful, let me give you a couple problems that I don't think you could solve right now. Definitely you couldn't solve them from what we have covered so far. So I said, well, what are the odds of getting heads at least once if you flip a coin 3 times? How likely are you to get heads at least once? A more complicated one in that you're going to see it uses a lot bigger numbers. If I rolled a pair of dice 6 times, what are the odds I'd roll snake eyes? Snake eyes being 2 1s at least once. Roll it 6 times. How likely are you to get snake eyes 2 1s? Like I said in class, I don't really gamble. I don't like to gamble all that much. But if you do, I think snake eyes are bad. I think think everybody loses or something. I don't know. I think you don't want to roll this. Anyway, guessing it wouldn't be called snake eyes if it were good, right? So, what are the odds of rolling this bad number? Nothing we've given you so far would tell you how to do it. You know, if you tried to use the addition rule, it might look like it's going to work, you know, 1 out of 36. It might not look stupid if you tried to use that on the second one here. It's like, well, we add them up. It's 1 out of 36 each time. So roll 5 times, we're going to get 5 out of 36. Or 6 out of 36, 1 and 6. That might look right. Might like, well, maybe that's not wrong. But if you try that method with the coin flips, it's like, well, 1/2, 1/2, 1/2. So your odds are 3 out of 2, 150%. That can't be right, right? So that can't be, at least in that simple form, how we solve this. Multiplication, well, that's not going to work, especially for the first one. If we try multiplying, we're going to get 1 out of 8. We know it's way more likely than that, right? Right? With any of these, and honestly, with anything you ever see in life that involves math, the smell test is always a good first one, right? If you get a crazy, crazy, crazy answer, you've probably done your math wrong or approached the problem in the wrong way, right? Well, how in the world would we do these problems? Well, the negation rule will tell us how. And as with a lot of hard problems or seemingly hard problems, if a sort of frontal assault, if just like charging at it doesn't work, a good way to come at it is often, kind of sideways, right? So, and the way to come at this sideways involves the negation rule. And the negation rule is this: the probability, well, let me give you the first step here. The probability that either A or not A is true is always 1, 100%. And this is true no matter what A and not A are, right? If it's you flip heads on a coin or you don't, well, you're either going to do it or you don't, right? The odds that you flip heads, 1/2, roughly 1/2. Odds that you don't, 1/2, going to equal 1, 100%, right? But you can take it for something way less likely, right? The odds that you draw an ace as the first card from a well shuffled deck, 1 out of 13. The odds that you don't, 12 out of 13. A is drawing an ace, not A is not drawing an ace. They're going to add up to 13 out of 13, right? Odds that you draw the ace of clubs on the first draw, 1 out of 52. Odds that you don't, 51 out of 52. Well, A, draw the ace of clubs. Not A, don't draw it. They're going to add up to 1, right? No matter how likely or unlikely A or not A is, they have to add up to 1. If A doesn't happen, not A is going to happen, and whenever not A happens, A will happen, right? Well, now think about this, right? If I say either A or not A, are A and not A mutually exclusive? Well, obviously so, right? If A happens, then not A is not going to happen, right? And if not A happens, well, obviously A isn't going to happen. So this is an or statement. Pretty obvious, A either happens or it doesn't. That is certain, that is true. Well, so A either happens or it doesn't. Probability equals 1, which is just a way of saying it's certain or 100%. Well, we can think, since this is mutually exclusive and it's an or statement, we can just use the addition rule, right? So the probability of A plus the probability of not A equals 1. Well, do a little, I don't know what grade this was in, but this is pretty simple math, right? If that's true, do a little bit of very simple math. The probability of A plus probability of not A equals 1. Well, a little bit of simple math tells us the probability of A equals 1 minus the probability of not A. Whatever A and not A are, you can also figure out the probability of not A. It's going to equal, well, 1 minus the probability of A, right? So the negation rule is for whatever A is, the odds that A is true is always going to equal 1 minus the probability or the odds that A is not true. Okay, so we've slow walked through this. Why is this interesting? Why is this useful? Well, it's interesting and useful because, realize it or not, we now have what we need to solve these earlier problems. Well, what's the probability of getting heads on 3 flips? Well, it is 1 minus the probability of not getting heads on 3 flips. All right, so if you could just figure out what's the probability of not getting heads on 3 flips of a fair coin, then you could use that to figure out what the probability of getting heads at least once is. Well, it's not too hard, right? There's only one way that you don't get heads if you flip a coin 3 times, and that's if you get tails every single time, right? The odds of getting tails on a fair coin flip, 1/2, 1/2, 1/2. Remember, these are independent. Don't commit the gambler's fallacy. So 1/2, 1/2, 1/2. What are the odds of getting 3 straight tails, which is the same thing as saying not heads 3 times in a row? 1/8. So now we have our number. We can finish our very simple little, I guess it's an equation, right? What's the probability of heads on 3 flips? 1 minus 1/8, which is 8 out of 8 minus 1 out of 8 equals 7 out of 8. The probability you'll get heads at least once on 3 flips is 7 out of 8. Way more complicated math. You know, this one I wouldn't even do as a fraction. It's easier just to take, the fraction and get a decimal number out of it. What's the probability of rolling snake eyes at least once? What equals 1 minus the probability of not rolling snake eyes on 6 rolls? Well, think about it. What's the probability of not rolling snake eyes? Well, there's only one way to get snake eyes. One die comes up 1, the other die comes up 1 too. Each of those has a 1 in 6 chance of happening. The odds that you get snake eyes is only 1 out of 36. So if the odds that you get snake eyes are 1 out of 36, the odds that you don't, again, using our little negation rule, are 35 out of 36. Well, 35 out of 36 each roll, the rolls are independent, so you just multiply 35 out of 36 6 times. The odds of not getting it 6 times, just use our multiplication rule, right? Now, if you have a nice calculator at all, the easiest, I'm never going to give you a problem this complicated, but if you run into something in real life like this, I don't know why. Maybe you like to gamble, maybe you just want to impress somebody with a weird little trick, might be useful somehow else. If you ever want to do this, the easiest way is just to, well, get the decimal thing and then multiply it all those times, or if your calculator has a little exponent function, just punch in 6, which is just saying we multiply by this 6 times. This is rough. This is close. This is not exact because these, we drop off a few of the decimals. But roughly the odds of not rolling snake eyes, 0.972 or 97.2, right? We multiply that out. 6 rolls. What are the odds that you roll 6 rolls and don't get snake eyes at all? 84%, or about 84%. It's actually 84.448 something. All right. Well, now we have that number. Probability of rolling snake eyes at least once on 6 rolls equals 1 minus 0.84 equals 0.16. If you really like percentages, 16%, thereabouts. All right. So that's how the negation rule works, and it's often pretty useful. There are a lot of problems that you will see that you can solve if you use the negation rule maybe with something you already know, or that you can easily get if you use something like the multiplication rule. So that's the negation rule. Gensler goes over it in a paragraph. He does an okay job of covering it. But like a lot of the things Gensler talks about, I think he goes just a little too quickly here. So hopefully that makes more sense of what it is and how it works.